In this video, we're going to talk about continuity of a function at a specific point. In order for a function to be continuous, it needs to follow three different rules. The first one being that the function at its limit point, or whatever we use as the limit point at a, needs to be defined. Second rule is that the limit of the function needs to exist. So that means both the left-hand and right-hand limits need to match. And then if both those criteria are met, the third rule is that the original defined function needs to match the limit value of the function. So we'll go over an example that we have written down here. So as you see, we have two different functions in a piecewise setup. And the first thing we need to do is to make sure that this function is defined. So only x value here, where it's actually defined as this less than or equal to value. So we have to use this function in order to see if it's defined. So we'll go ahead and plug f of 1. So we have a defined value, so that checks. So for rule 2, we need to get both the right hand, or the left hand, and then the right hand limit of this function, of both these functions. So let's start with the left hand. So our x value is only less than 1 for this function here. So we'll get the limit of our first one value on this function. And we get a 4. So for our right hand limit, since this x value is greater than the 1, obviously we'd be using this function to determine this right hand limit. So we'll plug 5 plus 2, and that's equal to 7. So these don't match, so it doesn't pass the second rule, so these functions are not continuous at point 1. Let's go over another example. Square root of x if x is greater than or equal to 1. All right, so we have two functions again at point 1. So let's just go down our little checklist here. So step 1, is it defined? So the only function that actually has an equal value for our one value is this second function here. So we'll go ahead and plug is equal to the square root of 1. That's equal to 1. And that checks. So rule 2, we need to find both the left hand and the right hand limits. So starting with the left hand, this x value is less than 1, so we'll be using this function here. So that'll be 1 square, and that's equal to 1. And we just get the square root of 1. That's also equal to 1. So both our left hand and our right hand limits match. So the limit exists. Now for our last rule. Does our initial function match our found limit? And they're both equal to 1. So graph of A is equal to the limit of our function x at x is going to 1. So it passes all 3 rules, so it is continuous at point 1. We'll go over another example here. X squared if 0 is less than or equal to x and then less than or equal to 1. And then we'll do one more function. So we got 2 minus x if x is greater than 1. So essentially we want to find that if these functions are going to be continuous at point 0 and point 1. So starting with point 0, we'll start with rule 1. So the only for point 0, the only function that actually has an answer 0 is this one here, since it's less than or equal to. So I'll plug the 0 into that. So f 0 is equal to 2 0 squared. That's equal to 0. So it is defined. Now going to rule 2, start with our left-hand limit. This value is less than 0, so this is the function we're going to be using for our left-hand limit. So equal to 2. So for our right hand limit, we'll use this function here. That's equal to 0. So both our left hand and our right hand limits don't match, so the limit does not exist. So it's discontinuous at point 0. Now for point 1. So we'll go down our list here. So once again, the only function that has a definite answer of 1 is this one, since it's less than or equal to 1. So we'll plug our 1 into the 2x squared. That's equal to 2. Now, we'll do it both our left hand and our right hand limits. And since this one's less than 1, we'll use this value. Now for our right hand. This x value is greater than 1, so we'll use this function. That's equal to 1. So once again, our limits don't match, so it does not exist. So this is also discontinuous at 0.1. So pretty straightforward. Just make sure that you have a good understanding of these rules here. Be sure to just check which function actually has a defined answer to plug in initially, and then from there just find your left hand and your right hand limits. So whatever the x value is less than or whatever it's greater than, and then from there just make sure you match them up.